All right, so the area, jeez, the area of that little shaded region is going to be the sector minus the triangle. Well, the sector is going to be, okay, guys, 90 divided by 360 times the area of the circle, because we're doing a percent of our area, which is pi r squared, which can be pi times 10 squared, minus our triangle is half the base, well, the base is 10, times the height, which is 10. And can someone tell me what that comes out to when you do all that work? Akshay. Can someone raise their hand, Amber? Akshay.
Okay, 25 pi minus 50.
Yep. All right, now I have to find the length, right? It says also find the arc length. So our length is once again going to be that 90 divided by 360, but rather than using the area formula, I'm going to use the circumference because we're looking for a length. So I'm going to get the entire circumference and multiply it by the percent, which is 90 divided by 360. Circumference is 2 pi, our radius, which is 10. Can someone raise their hand and not be Akshay because he gave me the last one? But awesome job. No shout-outs from Amber.
What if I shouted out?
Anyone got an answer? Anybody? Oh, yeah.
Five.
It is 5
Pi.
pi. Yep, we'll have 5 pi. Any questions on the arc length since we didn't have any hands going up? I don't know if we just didn't have time or forgot about it. Anything with circles are basically the same. Just figure out whatever the total is of what we're talking about. Remember we did annuluses? If I did part of an annulus, it's the same thing. Calculate the total annulus and then multiply it by the percent of the circle we're talking about. So that's generally when I'm dealing with circles and sectors and stuff is find the area, find the circumference, find the annulus, and multiply by that degree over 360. All right, are we good on that?
The end.
The end. Have a good day. No, I'm just kidding. I'm actually going to start off with questions from homework first, just because we're leading into the same section. Yes?
Can we do 7?
Number 7 in the chart. So if our ratio of areas is 9 divided by 64, well, that means the scale factor is the square root of both of those numbers. And the square root of 9, so just remember that if our length ratio is A over B, our area ratio is A squared over B squared. So in this case, our area ratio is 9 over 64. To get my A and B, you take the square root of both, which would be 3 squared over 8 squared. So we would have 3. And 8 would be my scale factor, and it would also be the ratio of perimeters.
But how do we do number 6 where it's just 1? Like 25 to 1.
25 to 1?
Number 6.
And number 6 is 25 to 1. What's the square root of 25?
5.
What's the square root of 1?
Oh.
Hey. Yeah, we just had one last minute addition. Yeah. That's right. Yeah. I trust it. All right, so what's the square root of 25?
5.
What's the square root of 1?
Just 1.
It's just 1. So it would be, the scale factor would be 5 to 1.
Oh, okay. Because I didn't. Okay, I wasn't thinking. I was thinking you can't square root 1, but you can.
Yep. All right, other questions? Akshay.
Well, it's not really get the answer on 11. I just want to know why you chose A, B, C, and M and all three similar triangles.
Why I chose them? I didn't choose them to be. It's just that because of the midpoints. they're the midpoints of those lines.
Wouldn't that, if you're doing ABC, wouldn't that be the like L, M, N then? Because like the median of AB is L. M's the median of BC, and M's the median of AC.
Element on the midpoints of the sides A, B, C. Find the ratio. Say that again. So I'll draw my triangle. All right, what do you want to happen?
I thought that like it had to be like AB would be similar to like LM instead.
All right, but you drew the picture the same as mine, where L is the midpoint here?
Yeah.
Okay, so we have L, M, MN. So I guess this would be the same as that. This would be the same as that. This would be the same as that. So I guess, what's the question, I guess?
And it's like for ABC, like I did like I originally did L, M, N instead of M, N, L.
You changed the order of these?
Here's like why you picked the order of M, N, L.
Because I put in the order, because they said they're the midpoints of A, B. It doesn't even matter. I could put L here. And it'd still be the exact same, so I could switch. That's what I was asking about your order of your letters. So I could make this.
No, I had the same order that you had. I just don't know what I was thinking though. I'm just, I don't know.
So what did you do differently, I guess?
I had like it's similar to like a different triangle. Like I didn't have M, N, L for like the triangle that it was similar to. I had like L, M, N. But I just don't
Oh,
know
I
why.
see what you mean.
I just don't know,
But it really doesn't matter. It's just that this is 1/4 the area of the rest of it. It doesn't even matter how you name it and what order you put it in, because each one of these 4 triangles is the same triangle. Because this side length is this, and this last one is going to be the one with the 2 on it.
Wait, oh, now I'm reading the question. I suppose did you really have to figure out what they were comparing the triangles, like what similar triangles were, or did you just
Find the ratio of the perimeters. So the perimeters,
so I just
you really didn't have to do you didn't have to come up with similar triangles at all. You just had to realize this length is the same as this length. This length is the same as this length. And so we have 1, 2, 3 of the same length, where this one has 1, 2, 3, 4, 5, 6. So it's just 3 over 6, which is 1/2 of the perimeter. And the areas would be, this is 1/4 the area of the total triangle.
you like that part I understood. I just
You did not have to come up with similar triangles.
yeah, that's when I realized that just now when I read the question.
Oh, okay. So you're good then?
Yeah.
Okay. All right, so we just have something that looks like that. All right, other questions? Yeah.
Maybe one. Like, I don't think I got, because like I drew 2 triangles.
Yeah, we didn't have to draw triangles.
Rectangles. I drew 2 rectangles, so I know.
Yep.
So like 1.
So that's what I have on the answer key. I have 1 kilometer equals 100 meters, equals 100,000 centimeters. So 50 kilometers is 5 million centimeters. So if it's 1 to 50,000, I just got to square both, and that's the area. Area is just a square.
Oh.
Other questions?
I didn't convert it like that.
Other questions going once? Twice. All right. Then we're going to today's. Today's a little more difficult, so I hope those people that didn't quite get today's done spend some time and get it done quickly, because this is going to be a longer assignment. And we're going to shortcut it just a little bit. All right. So we were talking about similar triangles yesterday, how we can compare similar triangles. If I have a ratio that's 1 to 2, the areas is 1, 2, 4. Well, this isn't similar, but they're very close. This is where they have the same height, but different bases. So if I look at triangle ADB and BDC, they have the exact same height. The only thing that's different is the base. So if two triangles have equal heights, then the ratio of those areas is going to be, well, let's just actually calculate the ratios. Let's calculate the ratio and see if we can come up with something. All right, so let's get the area. Let's go back to black. Fade to black. We'll have area of triangle ADB. And then we'll put that over the area. So this is the ratio between the two triangles. It doesn't really matter what order we put it in because they're not similar. So let's just do CDB. Well, the area of the first triangle is half the base times the height. Well, my base is just A for that one. So my base is A, and the height is H. Half my base times my height. Well, the other base, well, we have 1/2 the other base, which is B, times the height. But even without any numbers in there, what's 1/2 divided by 1/2? 1. What's H divided by H? 1. Everything cancels out. Everything cancels out. 1/2 divided by 1/2 is 1. H divided by H is 1. We just have A over B. In other words, you just have to take base 1 and divide your other base. We'll call it base 2. Base 1 over base 2, if they have the same height, will be the area ratio. Now, pay attention here. Did I square anything? Did we square yesterday when it's similar? Yes. If it's lengths, if I say they're similar triangles and I have length to length, we have to square it. If we know they have the exact same height, you're not going to square anything. You're just going to take base 1 divided by base 2. All right? So when dealing with same height, and we'll do it down here, same base, there is no squaring for the area. It's hard to do because yesterday's assignment was all squaring whenever you saw area. These two are different. We don't square. All right, so try to keep that straight. So we got a little nifty formula. How did I actually do it? So I just put it as, if they have equal heights, it's just the ratio of the bases. If you need to, put a little note that says you don't need to square. We aren't squaring anything here. I think that's the hardest part about this section, is because now we're throwing something at you where we no longer square it. So if you have similar triangles, you have to square the ratio. If you're dealing with same height, same base, you're not squaring anything. You're just going to leave it as is. All right, let's go on to the next one that says same base, different heights. If I look at triangle ABC over ADC, those two things have the exact same base, base B. So let's actually find the area of both of these. So the area of triangle ABC all over area of triangle ADC. ABC is half our base times our height. Well, our base is just B, so half of B, times our height, which is H. All over the area of ADC, which is half of base, which is B again. All over height, well, this height is K. Once again, that 1/2 cancels out with the 1/2. The B cancels out with the B because they just turn to 1. And we're just left with H over K. In other words, height 1 over height 2. Do you guys have a box in this next one?
Yeah.
Oh, I just didn't know if it was just my copy that doesn't. All right, so if two triangles have equal bases, then the ratio of their areas is just the ratio of the heights. Yeah?
So when we're doing the area of like the triangle over the triangle, is always the big triangle over the small triangle?
Depends on what ratio I'm looking for. What if I would say, let me finish this, of heights. What if I'd say, Akshay, what's the ratio of ADC to ABC? Then you need to flip it. You just got to be careful what order I ask stuff in. All right. Once again, same base, same height. Do not square to get your area. It's hard to do, and I'll see it on the test probably. Just try not to. That is just if they're similar triangles. All right, let's just do a couple examples here. I didn't skip anything here. All right, so it says find the ratio of the areas of ABC and ADC. So this is where it says specifically what order we have to do it in, right? So we're going to note that they have the same base. So we just need the base of triangle, the height of triangle ABC, which is 9, over the height of ADC, which is 5, which is actually our ratio of our areas. That is height 1 over height 2. All right, next one is ABC, ADC. Are these similar, same height, or same base? That's pretty much our three options. Amber?
Same height.
They're the same height. They are both AC is the height. So we just got to get the bases. Base 1, well, I'm looking for ABC. ABC's base is 9. So we'll have 9 over, well, maybe I should write same height real quick. So we are going to have base 1, which is 9, over base 2, which is 16. So it's 9 over 16. And remember, this is area. This is area, even though we're not squaring anything. Maybe I'll put that over here. This is area also. All right, our last one. Similar, same height, or same base? It's kind of our three options. Yeah?
Same height.
Same height. Oh, because they're both 8, right?
Yeah.
This one's 8, and so is ABC. So that means, so we have the same height. So our area is just going to be our base 1 over base 2, where we're doing ABC over ADC. So that's going to be 10 over 12. Well, I can simplify that. I can do 5 over 6. Might as well simplify if we can. Questions about that? All right. Comparing areas of triangles, just like I said, if two triangles have equal heights, it's the ratio of their bases. If they have equal bases, it's the ratio of their height. And if they are similar, then the areas equals the square of their scale factor. So that is the only time where you're going to square it, is when it is similar. That's the only time you have to worry about squaring it. All right, let's do a little more elaborate example. Let's look at regions 1 and 2. Are 1 and 2 similar triangles? Be very careful about this one, because the part that's in red is area 2. Amber?
No.
No. 1's not even a triangle. No, they're not. But what are two similar triangles? Remember, you got the last one. You got the super easy no. Robin.
ABC and ADE.
ABC is similar to triangle AD. All right, so we know something about those two areas, right? We know something about those two areas. What is the ratio of those two areas? Let us go from ADE to ABC. Let's go small to big. All right, can someone tell me the areas of the ratios from ADE to ABC, from small to big. Yeah,
Is it like 2/3?
not quite. You're close. Because 2 is the length of the small one.
Oh, no, 2/5.
Yeah.
2/5.
We're close. We're still close. So the ratio of areas it has something to do with 2/5 because those are our length ratios. What do I have to do to those? I have to square them.
I was just thinking, because you were talking before, you said don't square them.
Don't square them. I said don't square them unless they're similar triangles. Similar triangles tells you need to square those ratios of lengths. All right, so we have a ratio of 4/5. Now it says, what is the ratio of region 1 and region 2? Let's talk about what we're asking here. So we have region 1. So we have 1 over. Now, region 1, we already know, is going to be this 4. We're already done with that. All right, that's part of the ratio is done. Because this is, right here, this is 1 over the triangle BAC, or CAB, or however you want to put it. Yes?
So, for D, do we just subtract 4 from 25?
Yeah, we're going to subtract 4 from it because we have area 1 over, I want to figure out what area 2 is, so we're just going to get triangle BAC, that looks like an O, BAC minus region 1, right? Our total triangle minus this little section becomes just 2. Well, 1 in this ratio is 4 over triangle BAC was the 25 in the ratio. And we're just going to subtract away 4. So that's going to be 4 over 21. It's just going to be 4 over 21. So this right here, that equals my region 2. Do you all agree with that? That the triangle minus region 1 gives me region 2? Well, then let's just do that. The triangle is 25 in the ratio, minus 4 from the ratio, so it's 4 over 21. Questions on that one? Because they can get pretty complicated. Are we okay with that? All right, let's move on. Okay, 14, 15. It says find the ratio of the areas of triangle 1 and 2, and then do 1 and 3 for both of these. So let's start with A. A, we're supposed to do 1 to 2. So I'm looking at triangles 1 or 2, and I'm always asking this question. Similar, same base, same height. What do we think about region 1 and 2? Are they similar triangles, same height, or same base? Yeah.
Same height.
They're going to be the same height. So both of those are the same height. So we're just doing the ratio of their bases. In other words, base 1 divided by base 2 equals 8 divided by 5. Do I square the 8 over 5 because we're talking about area?
No.
When's the only time I square? Akshay?
When you have the same height or you have the same base.
When's the only time we do square?
Oh, do same length.
Yep.
Neither of those two.
Similar triangles. You are naming both the times where you don't square it. You named it both times where you don't square it. You do not square it if it's same height,
Then I
same
said
base,
then I said
and then you
neither
said
of those.
just same base. All right, so this one is same height, so we know not to square it. We're just 8 over 5. B, we are doing 1 to 3. Same height, same base, or similar. Sabrina, do you have an idea on this one? Region 1 and 3. Same height, same base, or are they similar?
I think they're definitely not the same base.
Correct.
They're not similar, so they have to be same height.
Same height. Do they look like they're the same height? If I put a line? Yeah, they're the same height. So once again, going to be the same height. This time they're going to be our base of our area 1, which is 8, over base of our area 3, which is 15. All right, last one for examples. What time is it? Okay, we'll get there. All right, so we have A. A, we have to do 1 to 2. 1 and 2, same height, same base, or similar? Hannah? Same base. Because they both have this base right here. They're sharing it. So we are going to go same base.
How do we know the measure?
They're sharing that.
But how do we know the measure as well?
I'm sorry, what?
How do we know the length?
How do we know the length? Oh, we'll get to it. So they're the same base. So we will get to it. All right. So 1 and 2, we're looking at the same base. And I actually circled the wrong one. We should be circling that one. Yeah, I don't know why I circled. I was just looking really quick. I was trying to write and circle. So that is the same base that they share. What was that? No, I'm trying to think the best way to do this right now. What's the length ratio between the two? Yeah.
7, 4,
So our length ratio,
for 1 and 2.
yeah. Our length ratio is going to be 7 to 4. So what's the height ratio between the two going to be? Since we don't have actual numbers, what's the height ratio going to be if the length ratio is 7 over 4? Yeah, it's 7 over 4 too. So our height ratio is just 7 over 4 as well. In other words, height 1 to height 2. All right, B is going to be a different one. Yeah,
So isn't it
1 to 3.
yeah, isn't it 7 over 4?
Is it 7 over 4?
Yeah.
Close. What kind of triangles are 1 and 3? Yeah, Robin.
Are they similar?
They are similar, and let's see why.
I
Well, we have vertical angles,
in a parallel.
and we have a parallel. So this must be the same as this, and as soon as I prove two angles, they must be similar. So since they're similar, we do have to square. So triangle I is similar to triangle 3. And so we are going to have 7 over 9 is the ratio between the two, but we need to square it to get the area, so it's 49 over 16. Because that is similar tells you to square. Similar tells you to square. Similar tells you to square. I actually want to change A. A does not have same base. I don't know. I was trying to see where you saw that, and I just kind of kept going with it. Do they have the same base? They have the same height. I was just trying to. 1 and 2 do not have the same base. The only way they're going to have the same base, really, is when they overlap. Where's a good example? Look at number 1 there. Same base almost jumps out at you because they have to pretty much overlap on each other. So that one does not have the same base, but it would have the same height. Because if I would draw like a height here, I draw a right angle, they both would have that same height. 1 and 2 would have the same height. So they do have the same height. And to find that height, we still use the length. So either way, you would have got the right answer, Hannah, on the test. You would have did the ratios, and then you did your height ratio. Really quick. So this is slightly harder homework. In particular, the back side gets a little harder. So I just want to kind of start off one with you. I'm going to kind of help you walk through 24. Here's what I prefer you to do. Don't write down what we're doing and then try to do it at home. It's all written down online. It's on my answer key. Everything I'm about to write down is online on the answer key. I would like you to look through it and then try it on your own at home. As soon as you write it all down, then you're just looking and going, oh, I could do that. I'd rather you have a blank sheet in front of you and try it. Okay. So let's start with A, because we have an A, B, and C. It says we are supposed to find the ratio of areas from 1 to 3.
Are we allowed to write this one down as
No.
an example? Okay.
No. This is your homework. I'd prefer you, because everything's written down online.
Right.
All right? I'd prefer you just have, when you go home, there's just a blank section there and see if you can repeat it.
Sure.
Okay? I'd prefer you not write this stuff down. Does that make sense? Because I still want it as homework, but I would like to walk you through so it's not like you're sitting here for 6 hours seeing what they want you to do. All right, this one we're comparing area 1 to area 3. Similar, same base, or same height? Amber? They are similar. They are going to be similar because it does say it's a trapezoid. So these are going to be parallel. We have vertical angles, so they are similar. And I think I wrote all of that down on there, why they're similar. But we have triangle 1 is similar to triangle 3. So that means when I'm comparing their areas, or our ratio of areas, we are just going to have 5 over 10 squared, which I'm going to simplify inside before I square it, which is just 1 over 2 squared, which equals 1 over 4. Once again, I prefer if you're not writing down what I'm writing down. I want you to try it on your own, Jacob, unless you're ahead of us. Unless you want to just put little notes to yourself or something. Do you think you could repeat this? Similar is the two things squared. All right, now we're going to go from 1 to 2. So we're going from 1 to 2. So B is we're going from 1 to 2. Same height, same base, similar. Akshay?
No, similar.
They aren't similar.
Is it the same height then?
It is going to be the same height. Because let me make everything else disappear really quick, and we'll just focus on those two sections. You
Is
see.
it like the big triangle thing?
Do you see how it's just a big triangle? Where if I get the height going through here, make a right angle, those are both the same height. So they are the same height. So for B, they are the same height. And that means I just need the ratio of their bases. Is there a length here or here? No. Do I have a ratio from this length to this length, though? So I'm looking for the ratio of this length to the ratio of this length, because those would be my bases. Can we get that ratio? And I'm going to give you a hint. Cover up 2. do we know the ratio from this length to this length if I was talking about 1 and 3? Do I know the ratio of this length to this length if I'm just talking about 1 to 3? Evan?
Is it the same, it's the same as,
So I'm kind of forgetting about that. Same,
like,
the one above it?
yeah, so it would be like, yeah, I don't know how to explain it.
So what would it be?
Like number-wise?
Yep.
It'd be, 4,
No.
wait, good.
What was our length ratio from 1 to 3? Just length ratio. It was 5 to 10, right? That was the length ratio, which would be 1 to 2. What's the length ratio of red to purple? Does it ever change? Does our length ratios ever change? No, they never ever do. So if I would just erase 2 for a second, and if I said, what's the length ratio from red to that, you would just say it's 1 to 2 or 5 to 10. So when I bring 2 back into it, does the side change? The ratio is still 5 over 10, in other words, 1/2. It's just the side ratio because it's base 1, base 2. Are we okay with that? I'm very quiet about it. Jacob, are you okay with that? Okay. Which is why we're on number C. All right, C says we're supposed to go from 1 to 4. Can someone give me a guess? So it's going to be the same height again, just to speed things up. What is the ratio from this base to that base? Yeah.
It'll be the same as the other thing.
It'd be the same as the other thing.
XP.
So it'd be still 1 over 2, right?
Yeah.
Yep, because it is still comparing length 1 to length 3. So we have 1/4, 1/2, and 1/2. The final, or we are supposed to do 2 to 4, slightly less interesting. They're the same, right? So 2 to 4 would be the exact same because they both would be the 2 and the 2, which would be the exact same. So E, or D I should say, would just be 1 over 1. All right, E is the most interesting one. E is going to be, yeah.
Wait, why is D 1 to 1 again?
D is going to be one of the ratios between them because the ratios are the same to this one, 1 to 2 and 1 to 2. So if they have the same ratio to this one, they must have same ratios to each other. So E is, we're supposed to do 1 to the trapezoid. Well, 1 to the trapezoid would be area of 1 over area of 1 plus 2 plus 3 plus 4. That's not my 4. I just was going to make all ticks. Which is going to equal, well, we have 1 for area 1. So I'll fill that in for both places. Area 2 was my C, which was that 2, because it was 1 to 2. So it's 1 over, that's going to be 2. Area 3 was this one. That was our 1 over 4, so I'll have 1 over 4 here. And finally, 1 to 4 would be D. I think it was D or one of these, but it's also a 2. And that would be our total thing. All right? So that is all online for you to check out.